Pepper anthracnose, caused by the fungus Colletotrichum spp, was first reported in the early 20th century. However, the precise date of discovery can be vague due to variations in documentation over time and different locations. The disease has been known to affect various crops globally for many decades, and its identification in peppers specifically might have been documented initially in local agricultural reports or studies concerning plant diseases. If you're looking for detailed historical data or a specific discovery date, consulting specialized agricultural literature or historical archives of plant pathology might be necessary. Pepper anthracnose, primarily caused by the fungus Colletotrichum spp, initiates its infection route when spores are dispersed by rain, wind, or via contaminated tools and equipment. These spores land on susceptible parts of the pepper plant, such as the fruits, leaves, or stems. Favorable conditions for the fungus, particularly warm, wet, and humid environments, promote the germination of these spores. Once the spores land, they begin to germinate and can penetrate the plant tissue either through natural openings like stomata or through wounds on the plant's surface. Following penetration, the fungus starts to colonize the plant tissues internally, developing structures known as opressoria that facilitate stronger adhesion and deeper penetration into the host tissues. As the fungus continues to spread within the plant, symptoms begin to appear. On fruits, this typically manifests as sunken, water-soaked lesions that darken and may display a concentric pattern. These lesions can grow quickly under ideal conditions, leading to significant fruit damage. The development of lesions is crucial for the disease's life cycle, as these areas produce masses of new spores that contribute to secondary spread. These spores can infect other parts of the same plant or spread to new plants, exacerbating the outbreak. Moreover, the fungus has the capability to overwinter on infected plant debris or within seeds, thereby sustaining its presence in the field and initiating new infections in subsequent growing seasons. Managing pepper anthracnose effectively involves implementing rigorous sanitation measures, utilizing resistant varieties when available, and applying suitable fungicides. Additionally, controlling environmental conditions to reduce humidity around plant surfaces can help minimize the risk of infection. Early detection and prompt management actions are critical to preventing significant impacts on crop yield and quality. Pepper anthracnose, primarily caused by the fungus Colletotrichum spp, is characterized by several distinctive symptoms, with the most significant impact often seen on the fruits, although leaves and stems can also be affected. Initially, the fruits develop small, water-soaked spots that are slightly sunken. As the disease progresses, these spots enlarge and deepen into well-defined, sunken lesions that appear darker, often brownish or blackish, in their centers. A notable feature of these lesions is the development of concentric rings, giving them a target-like appearance. This pattern occurs as the fungus produces spores in cycles, contributing to the spread of the disease. The expanding lesions can lead to considerable fruit decay, which not only diminishes the fruit's aesthetic and commercial value but also makes them prone to secondary infections by other pathogens. This further deterioration compromises the overall quality and marketability of the fruits. In addition to the damage to fruits, the fungus can also infect leaves and stems, though these symptoms are generally less severe. Infected leaves and stems display dark spots or lesions that, while less dramatic than those on the fruits, can still contribute to overall plant stress and reduced vigor. Another consequence of the infection is the premature dropping of fruits from the plant, which significantly reduces yield. The severity of pepper anthracnose symptoms tends to escalate under conditions of high humidity and warm temperatures, which are ideal for the growth and dissemination of the Colletotrichum fungus. Effective management of pepper anthracnose includes environmental control to reduce humidity around the plants, use of resistant varieties, application of fungicides, and good field sanitation practices such as removing infected plant debris. These strategies are crucial to mitigating the impact of the disease and maintaining healthy crop production. Treating pepper anthracnose effectively involves a comprehensive approach that combines cultural practices, chemical controls, and the use of resistant varieties when available. Starting with cultural practices, it is crucial to implement crop rotation by avoiding planting peppers or other susceptible crops in the same soil consecutively. This reduces the spore load in the soil. Sanitation is also key. Removing and destroying infected plant debris from the field at the end of the growing season helps minimize the source of the fungus for the next season. Maintaining field hygiene by keeping fields weed-free and managing debris can reduce habitats for the fungus. Proper spacing between plants is important as it improves air circulation, helping leaves and fruits dry more quickly and reduces the humidity that encourages fungal growth. Additionally, irrigation practices should be managed carefully. Avoid overhead watering to minimize wetting of foliage and fruits, and use drip irrigation to keep the plant surface dry. During harvest, careful handling of fruits to avoid wounds can prevent creating entry points for the fungus. Chemical control is another critical component. Fungicides containing chlorothalonil, mancozeb, or copper-based compounds have been found to be effective in managing anthracnose. It is essential to begin fungicide applications early in the season and continue at recommended intervals, particularly before rain and during wet conditions. To prevent the development of resistance in the fungal population, it's important to rotate fungicides with different modes of action. Where available, using pepper varieties that are resistant or tolerant to anthracnose can also significantly reduce the severity of the disease. Regular scouting and monitoring of the plants for early signs of infection are crucial as well, as early detection allows for timely interventions, critical in managing the spread of the disease. Implementing these strategies in a coordinated manner provides the best defense against pepper anthracnose, adjusting practices according to local weather patterns and field conditions, and following advice from local extension services or experts tailored to specific regions for the most effective disease management practices.